Moving on to load control, let's do a load control test at 5 Hertz again. So we set up a dynamic cyclic load test, choose 5 Hertz. Again, we need to set the datum for the controlling parameter to be close to the existing datum. So we'll set 1 kilonewton, an amplitude of half a kilonewton seems a reasonable range. And the stiffness estimate is important because the system needs to know approximately how fast to run. If we set a very high stiffness estimate, i.e. a very, very stiff sample, the system needs to know that it doesn't have to move very far to achieve its desired load. Whereas if we know we have a very soft sample, we put in quite a low stiffness estimate, because the system actually needs to know it needs to be more aggressive and needs to really have some velocity to achieve its load. So it's important for the user to give the system a little bit of a guide with the stiffness estimate. Now we've seen from our displacement control tests that about plus or minus 2 millimeters generated around plus or minus half a kilonewton, which essentially means we've got a stiffness estimate of 0.25 kilonewtons per millimeter. So I'll enter 0.25 kilonewtons per millimeter as the stiffness estimate and continue. Enter a cell pressure. Again, let's have the number of cycles as 25 like last time, and let's just remind ourselves what cycles on and cycles off means. We've seen that when we do a short number of cycles, say 25 cycles, we can easily download all of those cycles at 100 points per cycle and display that on the screen. If we want to do a very, very long dynamic test, maybe one that's going to last a number of hours or even longer than a number of hours, half a day at maybe 1 Hertz, that's an incredible amount of data for the software to extract out of the control box. And as we've seen, the data comes back into GDS Lab at a slower rate than the test actually runs at. So if we know we have a very long test that's going to last a number of hours, we can set to maybe save 2 cycles in every 10, or maybe 10 cycles in every 50, by having the number of cycles on as 10 and the number of cycles off as 40. This allows us to run the test much quicker because there's not so much data to extract back, whilst hopefully still having a representative number of cycles for that long test. In this case, because we're only going to do 25 cycles, we'll extract all of those cycles for our testing purposes. So we'll add this to the test list. We'll say go to test and next stage. Now it should run a load control test. Five Hertz load control, and there's a very pleasing plus or minus half a kilonewton sine wave appearing on the display, which is fantastic. Okay, that brings to an end our video. Thank you for watching. I hope you found it informative and useful, for particularly when you're first using your system. Don't hesitate to contact myself or anyone at GDS for any help in the future if you have any questions. Thank you very much.